Welcome back. So before going any further, let's talk a little bit about what databases are and what makes them different from other sources of data. Um, the most important differentiation between databases and other types of sources of data is especially in terms of the most common databases out there and that have been around for the past few decades is a structure. So when you think of structure, think of more like a relationship. So most databases are modeled in terms of relations. So let's, for instance, talk about the employees database that we're going to look at. So when you think of employees, you think of a company, and a company has employees. Those employees are in multiple departments. Each department has its own roles. Each department has uh, managers, team leads, all that kind of stuff that you're typically used to. So when you're looking for somebody uh, uh, in a company, you probably need to have some sort of information like which department they work in, maybe what their role is, what their name is in the like what they're referred to as in the like what's on their ID, what's on their badge. So this is basically what databases are modeled after. So when we look at the employees database, you will see that's exactly what we have. So that kind of structure is basically what forms a database. And also, this type of structure actually helps in optimizing searches or querying the database because everything is organized for quick retrieval and also for updating pieces of data. Database design is a whole topic of its own, but if you design a database in an optimal way, it should be very easy for you to query, to retrieve information, also to store it. So it's in a database, you don't have all the information in one place. Usually, it's pieces of data scattered across certain types of stores. These are basically called tables, and there's a whole reason and motivation for designing things like that because it makes it easy not to store everything in one place. It makes it easy to basically find relationships and then retrieve only the information that you need. So think of storing all the information that you have uh, in one file. And let's say basically you're storing the names of people or the information of people one line at a time in a very big text file. And let's say you want to find a person, maybe let's say you have the database, your data in your text file sorted in alphabetical order, and you want to find somebody whose first name starts with say M. So it may look like that in databases, but it's not really efficient if you just start from the beginning and go all the way to M. What if the person's name starts with a Z? So um, if you're storing information like that as a bunch, then retrieving it makes it very suboptimal and efficient. So there is a reason behind why we design databases as a set of small structures then that can link to each other. That way we can basically trace our way to find the specific piece of information that we need. So in practice, this makes it very fast to retrieve information and also to store information. Usually storing information is a bit slower, but especially for the purpose of this module. We're mostly interested in retrieving or reading information, or in the database sense, we're more interested in querying databases. So this is in brief what databases are. So moving on to the types of databases, I've mostly been talking about structured databases, which are also called, for the reason I just talked about, relational databases, because they are organized as relationships between entities. These entities may be for our employees database, the employees, the departments, the heads of the departments, the names of employees, all the information that you would have in a company. But recently, other types of databases have been developed because of the need for not having structure. Mostly today, you will see databases called NoSQL databases that do not use structured query language. These types of databases usually store data as a set of documents. So these types of databases, they have their own advantages that they try to solve when over relational databases. Usually, if you're not doing lots of data manipulation, if you're more interested in storing and retrieving information, these kinds of databases may be more practical for your business needs, but we will not dive deep into what the major differences are between, but it's for this module, it's good enough that you know the differences, like they're more of like a collection of documents. So if you've ever heard of JSON, which is short for JavaScript Open Notation, this is the kind of data structure that many software systems use to communicate with each other. If you've also heard of APIs, or application programming interfaces, usually they exchange data uh, through such a standard format called the JavaScript Open Notation. And many of the NoSQL databases, they represent data in a similar structure, which is usually referred to as a document. I will include a few links at the end of this module, that if you're interested in, that you can read more about NoSQL databases. One of the most popular NoSQL database out there is called MongoDB. Um, it depends on your needs, but it's very efficient, especially if you're developing, um, some small applications that do not need the complexity of structured databases. So moving on, what are the common database operations that we can perform on databases? Usually you have the four basic operations on databases that are called the CRUD operations. You create, you read, you update, and you delete information. So CRUD. In most common terms, basically what you're doing is you're adding data into your database, you're reading data from your database, you're updating the database, or you're getting rid of data from your database. So either way, it's storing information, manipulating it, or retrieving it. But when it comes to data science, we usually are interested in data that has already been stored, and we want to learn something about it. So we may perform some sort of operation, but we just want to obtain information from that kind of database. So when you're querying your database, asking, for instance, the employees database, how many employees are in this department? You're not manipulating data. You're just trying to extract information. And in data science, you work with the data you're given. you don't manipulate the data to get to a result. So because of that, when it comes to data science projects, databases are mostly used to read information from, not to store information in, or not to manipulate, or uh, as you may already know, not to obviously not to delete the data that is stored in databases. So this is what makes it very specific. Reading operations are very specific, like a very particular for data science. So in this module, we're not going to go deep into the other operations. We only focus on reading or retrieving information. So we're not going to update the database. We're not going to delete anything from the database, and we're certainly not going to be adding um, any data into our database. So we will very specifically focus on uh, read operations in structured query language. Those operations are called select statements because we're selecting information from a whole trove of data stored in the database. So let's move on to the next section and dive deeper into how we can do these operations and do some more interesting stuff.